Now I would like to introduce Jay Greenbaum, and he will be presenting IEDB Tools 3.0, the future of tools. Thanks very much, Jay.
Sure. Thanks, Nina. Thanks, Mahita. All right. Yeah. So I'm Jay Greenbaum, and I'm happy to be able to present to you a project we've been working on for quite a while now, redesigning the tools website. And here we go. Oh, are you able to see my screen?
Now we can, yes.
There we go. Okay, sorry. Right, and so I will start with some motivations behind the work, and then kind of try to lay out what our overall vision is. And then I want to spend most of the time in a live demo. So hopefully we'll get to do that and everything will go according to plan. And then we'll come back into the PowerPoint and just talk a little bit about the plans and the timeline, and then introduce you to the team, the people that have actually been doing all of the work. All right, so why are we working on a redesign? If you're familiar with our website and you've used it a lot, you might have noticed that the navigation is a bit lacking. Sometimes it's hard to find the tool that you're after, or it's difficult to kind of navigate between tools. And so that's kind of a complaint that has come up over and over, and it's something that we want to address. Also, there's no linkages between the tools. So you can't, for instance, run a binding prediction and a processing prediction on the same set of peptides. And you can do it, but you have to do it in two separate windows or two separate calls. And there's no way of kind of linking them up and passing the same data between tools. So that's something that we want to address. And then there are certain inconsistencies among the tools, things like control elements might look different or might be named different, and just naming conventions in general. Look and feel can be different between some of the tools. So we want to kind of unify that. And then the website, it was initially developed in the early 2000s. There's been a lot of improvement since then and a lot of things added on, but the layout and the aesthetics have kind of largely remained unchanged since then, and we want to kind of bring them into the modern era. And overall, we know we can do better than what we're doing now. And so the vision is really to completely start from the ground up and rethink the user experience, with the goal that a new user should be able to come to the website and feel at home and immediately know what to do and how to get started using the tools. But at the same time, we want to provide enough functionality so that power users or users that regularly use the site are able to get done what they need to get done and perform these complex workflows. And so we want to do all of that by emphasizing things like navigation, so making it easy to find the tool, interest, navigate between tools, make sure things are simple, kind of abstract away a lot of the more complicated things from the user, and just make some sensible defaults as use some sensible parameters for the defaults. Consistency between the tools, so making sure all the control elements are similar, things look the same, things are where you expect them to be. And then integration is a big thing. So being able to send data between tools and kind of build these pipelines that I'll talk about a little bit later. And then of course, speed. So we want to be able to accommodate kind of real world use cases, semi-large data sets in a reasonable amount of time. So that's a big concern of ours, is to be able to do that. And then we want to do all of this by drawing upon things that are really familiar to us, things that we know that work. So things like REST APIs, JSON as a data exchange format. And while not using it directly, just kind of drawing inspiration from Jupyter and the way Jupyter notebooks work. And I think with that, we're going to switch over to our prototype. And let me just open that window up. Here we go. All right, so this is the main page on our new prototype. And what we have is kind of the main information in the center of the page, which is our tools. And specifically, we have kind of these tiles for each of our most heavily used tools, with the most more heavily used tools up top, and then moving down to the bottom of the page, we would have tiles for other tools. And the idea here is that we want to provide kind of the minimal number of inputs for a user to make things simple, so that you can get to work right away and get a meaningful prediction done. So here, for instance, for the T-cell prediction tool, which is the main tool that we've been focusing on and spending a lot of time on, the only inputs we provide on the front page are input for a sequence, so your protein sequence, which you can enter data here or just go with the example that's pasted in here already. And then an allele autocomplete box where you can just type in there and pick the allele that you want to go with. And one of the cool things is now you don't have to type anything in, you can just hit this play button, and that's going to bring you to the new T-cell class 1 page, and it's going to immediately populate it with whatever sequence you pasted. Since I used the example, that's what's pasted here, and whatever allele you selected. And then it's going to go ahead and choose some other sensible default. So we, by default, just choose peptide length 9 and our recommended binding method. And so as you come to the page, when you hit that play button, the prediction is already running. And so now we've given it enough time so that the results have popped up down below. And so we have the results as a table. And this should look pretty familiar if you're used to, if you've used our current website, where we have one row per peptide, an allele, and the associated prediction information. We're using a library called data tables here that has a lot of nice functionality already built in. So you can do sorting on the various columns. You could do multi-sorting. You could do filtering. So there are text filters. There are numeric filters. And you can also click on this button here, which will allow you to change the columns that are displayed on the table. So when you click on that button, you get this window that pops up that describes all of the columns in the table and will allow you to go ahead and select or deselect them if they're not interesting to you. It might make the data easier to look at without some unimportant columns in the way. And so now I'm just going to kind of go back up and walk through the controls from the top and do a more interesting prediction. And so if we start way at the top here, we have our input sequences. And there are two little buttons here. One of them is the download button. So this will allow you to download the sequence that you had provided here in a couple of various formats. Or you can upload a sequence. So you can do that by using your file browser, or what I'm going to do is to drag a sequence from another window here. So I'm dragging this file. You could see the box is kind of jiggling to let us know that it's ready to accept input. And then I dropped the file in there, it read it, it parsed the sequences, and it tells us I have 4 sequences in there. So these were 4 dengue sequences that I pasted. The other thing you might have noticed is now there's this kind of yellow highlighting around the box and this note that says the parameter has changed since prediction. And the point of that is to let the user know that you've already run a prediction, you have output already down below here, but now the inputs that you provided don't match the outputs. And so we're just alerting the user to that fact. Scrolling down, we have this prediction parameters section. The first thing there is a button where you can download your parameters. This will download the parameters as a JSON file, and that JSON file can be used with our standalone tool. It can also be, it's also provided in a format that, I'm trying to drag this window over, I can't right now. That's okay, it's not super interesting. It's also provided in a format that our API can use, so you can post to the API with that data as well. Next, we have our peptide length slider. So by default, we set it to 9. But this is actually, there's actually a range selector here. So you don't have to just do one length, but you can say, I want to do 9 to 12 or 9 to 15 or whatnot. I'm going to leave it at 9 for now. There's also an as is checkbox. What that does is that will allow you to come in, instead of with a set of protein sequences, full length proteins, you can just put a list of peptide sequences up here, and then it will not chop those up into overlapping 9 mers or 10 mers or whatever you select here, but it will instead use those peptides as you provided them. Next, we have our allele autocomplete, which not too surprising. You just can do lookups here on different alleles, and it will search based on synonyms and names, and it's pretty fast to populate and allow you to select. As you select, these get included as these chips in this little box down here. We also have been working on an allele finder where we're planning to present kind of a hierarchy tree view of the alleles and make it easy to browse. Right now, the main functionality that's in there is to quickly add the 27 allele panel, which would look something like this. For the purpose of this demo, I'm only going to run a couple of alleles. So let's go back with our trustee of 201, 101. Right, so we have 2 alleles selected. And then we get down to the section where we actually select the prediction methods that we want to use. And so by default, we have NetMHCPan-EL selected. This is a drop-down though, so you can change the method that you want to run, change the binding method you want to run. But now you can, not only can you just run the binding method, or one binding method, you can run multiple binding methods. So if you click on this, add another prediction. Now I'll add back in NetMHCPan-EL 4.1. And then we can also add our immunogenicity predictions. We can add our processing predictions. And here we'll select NetCTLPan. And with each of these selections, a context-specific menu comes up. So there are a few options for immunogenicity that come up. There's some options for NetCTLPan that come up as you select those methods. And now when we click run, it's going to run everything. So it's going to run the 2 binding methods, immunogenicity, NetCTLPan, length 9, 2 different alleles. And so as I submitted, you might have noticed I got this warning. If we expand that, the warning is going to tell us that HLA-A 101 is not available for COMLIB Sydney 2008. And so the idea there is that allele actually is available as a, we do have models for some of the other methods here, like for NetMHCPan-EL, but we do not have it available for COMLIB Sydney. We didn't want that to prevent anything from going through, but just to let the user know that don't expect results for COMLIB for this allele. And so now you can see we ran the prediction, and we have now a much bigger table down below. I'm going to shrink it down a bit, look at the first 10 rows only. So we can kind of scroll horizontally and see we have the median binary percentile, COMLIB columns, net MHC-PAM columns, immunogenicity, net CTL-PAM, and so on. Those little numbers up top, this 1 and 2 and so on, indicate the default sorting that's happening at this time. And now if we go to our, you know what, I'm actually going to change the sorting first, just something random. And now if we click on our display columns box, we can see now we have a much bigger set of columns, and each column has its description and is grouped by the individual prediction method that it comes from. And I'm going to just deselect a bunch of stuff here because I want to show you how we can now use some of this information to do pipelining, to build pipelines. So now I've deselected most of the stuff, and I'm only showing some of the columns that I want to now filter by. Actually, before I get there, I forgot there are a couple more tabs I wanted to go through here. So the binding and the processing and immunogenicity, they all have tabular output. So they all have this peptide table as output. But the processing can also produce plots. And so the plots are incorporated on another tab. And so we see we have data from NetCTL-PAM. We can kind of thumb through the different plots here, depending on which input sequence we want to look at, and for which allele. And we can change the percentile rank threshold to do different highlighting here. And then there's another tab that's the sequence table. And so this just kind of echoes your input sequences, but assigns a number to them. And then that number is used again in the processing plots table and the peptide table to let you know the sequence of origin for each of these peptides. And so now if we come back here, now let's do some filtering. So say we want to just filter on our median binding percentile. We'll take everything in the top 10%. And then we could do the same thing with net CTL-PAM, just take everything that's in the top 10%. And you'll notice that now we're getting this yellow highlighting again around our table. And it's asking us to save the state of the table. So the purpose of this is we need to commit the state of this table to the backend so that we can then now send the filter data along to another tool. So we could play with this table as much as we want and just not save the table state. But if we do save the table state, we can then use that to now send that data to the next tool. So now I'm going to open up this pipeline map again. I kind of hid it away at first because I didn't want to talk about it until now. And so this now will allow us to, it shows the step that was run. So we ran a T-cell prediction class swarm, and it will now allow us to take the output of that and send it now to different tools. So we're going to go ahead and just send the peptides to the cluster tool. When we do that, the peptide column gets highlighted to indicate that that data is going to be sent to another tool. And then we get a new set of controls down below that are inputs to the cluster tool. So we can choose the sequence identity threshold. We can choose the peptide links that are included, and then an option for the clustering method. I'm just going to go with the defaults here and click run. And so now it's taking those 94 peptides that we selected and running the clustering tool. And it looks like we have output now. And so this is clustering peptide sequences according to sequence identity. And we have a tabular output. We have a visualization that indicates the relationship within the clusters between the different sequences. If we go back to our peptide table and say we want to now take these clusters and send the consensus sequences along to another tool, we would just filter here on consensus sequence. Now our table is highlighted in yellow again. And we're going to go ahead and now say, we want to send our consensus sequences over to the PepMatch tool. And I almost forgot, we need to, let me cancel that. We need to save the table state. So we'll save the table state. And now we're going to send that over to the PepMatch tool. And so similarly, a new set of controls pops up down here. And we have parameters specific for PepMatch. So we could look with up to X number of mismatches. The default is 3. The default is looking in the human proteome and reporting the best match per peptide. So I'm going to go ahead and click run. We haven't quite optimized the way PepMatch is integrated just yet. So this one takes a little bit to run. While that's running, let's take a look at the way the pipeline map is organized. So at the top, we have this info box where you can type you could give a name to the pipeline. You can put your email in there. And what that does is it will then send you an email as each step completes and give you a link to return back to the pipeline. So it looks like PepMatch finished, but let's continue looking through the steps here. So the next section down lists the steps in the pipeline. So we ran the T-cell prediction class 1. If we expand these boxes, we can get a sense of what parameters were used. So we ran the 2 binding methods, immunogenicity, processing with 1 length and 2 alleles. The little table icon indicates that results are available. The filter icon indicates that they've been filtered before they've been sent to the next tool. And similarly, as we expand each of these, we can see all of the relevant parameters that were used within each of those tools. Let's go back down to PepMatch. Again, we got a bunch of warnings. This time it's that we have X's in a lot of our sequences, and currently that's considered invalid output for PepMatch. And so what happens is it just lets us know, and it will just ignore those sequences. They won't get sent on to PepMatch for prediction. But our PepMatch output then looks something like this, where we have the input sequences from above, the sequence that it matched in the database, along with the associated gene and protein information, how many mismatches, where were the mismatches. And so what we've done here in this pipeline is we took a set of 4 dengue sequences, ran binding, immunogenicity, and processing predictions, picked some of the top sequences, sent them over to the clustering tool, defined some cluster consensus sequences, and then ran those against the human proteome to see if there were any sequences that were close to sequences that exist in the human proteome. And the last couple of things that I wanted to show you on here, actually, before I forget, each table has a download button as well. So you can download all of the rows in TSV or CSV or JSON format. Or if you do filtering, you can download just the rows that are displayed. as well. That's a handy feature. Going back to the pipeline map. So I think the last thing that I, excuse me, that I didn't talk about just yet was the this little clipboard here. So if we expand this clipboard, we see we have a few links here. One says link to this pipeline. If I copy that URL and then paste it into another tab, that's going to bring me back to this exact pipeline. So to bring me back to this pipeline with all of the parameters that have been pre-selected and with the input data and with all of the output data loaded, if the output is, if the pipeline completed already. And so that is handy for sharing these links around. And if you want to rerun the same pipeline again, our goal is to be able to maintain these links long term. So ideally, we'd be able to use these links in a publication to in an effort that somebody can reproduce your analysis. There's also the second link down says link to pipeline configuration. And if I copy that and now open a new browser window, that's going to take me to this pipeline. But the difference is this is just the configuration that we chose. So it doesn't include any input data. It doesn't include any output data. It just includes all of the parameter selections that we made. And similarly, the idea here is these are going to be links that you can share. If you don't want to share your input data, you don't want to share your results, you can at least share the process. And I think the last link there is, well, it's not a link, but this will copy to your clipboard the post request that we send to our backend API if you're interested in using the APIs directly. I'm going to show you just real quick how that works by going to our API documentation. So we're using Django REST framework, which lets us, makes it easy for us to provide this documentation in Swagger format. And we're just going to go to our pipeline endpoint and just, I'm going to paste in exactly what I copied just now, which includes all of the, let me make this a little bit bigger for you guys. Okay, that looks a little weird. So it includes just all of the information that's needed to reproduce the pipeline, right? The alleles that were selected, the binding methods, and all associated parameters. I'll hit execute, and what I'm going to get in response is I get this immediate response that lets us know, okay, this is a valid request, 200 response, and it will give us a URL that we can pull for when the result is ready. So right now it's telling me it's pending. It's not quite ready yet, but it did give me some data back. It gave me the input sequence table, right? Because it parses that pretty quickly. The input data, this was all the parameters that we selected. And then it also immediately gave me that warning that we saw before about COMLIB. Hopefully if I refresh now, we should see that it's complete. Yep. So we see status done. And now we have more data in the results. So we have a peptide table. And with that peptide table, there's a description of all of the columns. And then we have the NetOHCPAM table, and we have all of our processing plots, and we have the input sequence table. And so the goal is that our front end is our front end is using these APIs, and ideally, we're going to make these APIs friendly enough so that our users can make use of them as well. So I think that's mostly what I wanted to show you guys in the demo. I'm going to see if I can find my PowerPoint again. And just go through the last couple of slides here. Yeah, and this is real quick. So there are more features that are planned, including writing packages in various languages, so that to kind of abstract away some of the details from users, so that you can use the APIs a little bit more easily. And then one of the goals also is to have kind of parity with our standalone tools. We are using the same input and output formats on both the web API and the standalone tools. So kind of unifying that whole universe together. And then we've been thinking about developing a set of curated pipelines. So if there's some use case that we see over and over again, we would establish a place where we can put these curated pipelines with descriptions, and potentially even open it up to the community for contribution of your own pipelines as well. And then what we're working on currently is improving the performance by moving all of the computation over to HPC backend using a queuing system. And we will have that ready for users to test very soon. And so we have that T-cell tool that includes binding, processing, immunogenicity. We have the clustering tool, we have PepMatch. Those are all pretty much ready to go, aside from the backend cluster. And then the next tools that we'll be working on will be the MHC class 2, some cancer-specific tools, and B-cell as well. And then this is the team. So Kevin and Jan have been leading the charge on the front end and the back end respectively. And then we've done a lot of consultation with a team at UES to help with some of the design decisions. Yeah, contributions from all over the place on this one. And that's all I have, and I'll take any questions. Thanks.
Thank you so much, Jay, for that wonderful presentation and live demo. Live demos can always be, a little bit hit and miss, but that was perfect. So thank you. Just to reiterate a few points, just because I do have a couple of extra minutes and I'll give Jay some time to look at the Q&A. This project has been, a few years in the making, and the workshops like this give us an opportunity not only to show you tools that have been around for a while and teach you things about them, but it also allows us to show you the work that's in progress, not yet live, and that's undergone many, many iterations. So this IEDB Tools 3.0 is just one example of this. It has undergone multiple rounds of user testing within the IEDB team. As Jay just mentioned, we've also engaged external usability experts to, better create the workflow, and it has gone through considerable work, changes, feedback rounds in a real iterative design, test and release format. So we'll hopefully get that to you so you can test it out in early 2023 with that pipeline workflow that Jay just showed you. And I think, to reiterate again, that the power of the new tools platform is that pipeline function. So taking the output of tool 1 and using that as an input for tool 2, and so on and so forth, in a much more seamlessly integrated way than is currently available. So basically, we've listened to our users over the years where this is something that they wanted, and it's taken, quite a bit of time, but we're in a really good place to hopefully release that to you soon. So thank you. The last thing you might have noticed was the PepMatch tool as well that Jay was showing. So you heard from Dan earlier today, and we did not show you that on the existing site because we made the decision to include that on the new site as well. So that was a quick point if you picked that up as well. But now I would like to introduce our final Q&A for the day. So it is with Mahita and Jay. Mahita very kindly addressed the few B-cell related questions in the chat via typing. I'll go through and just for clarity, restate the question and just repeat what Mahita has answered for each of those individuals as well. And then we'll throw it over to Jay shortly to answer the next one. So the first question was from Alejandro Pina, and it was, what is a recommendable threshold value for epitope prediction? Or it depends on the antigen being evaluated. And Mahita's kindly let us know that it does depend on the antigen being evaluated. Also, since conformational epitopes can span multiple chains, it would be recommended to modify the chain IDs of an antigen containing multiple chains into a single chain ID so that the epitope residues can be predicted more accurately. So thank you for that one, Mahita. And if you would like to take a look, that written response is also in the answered column of your Q&A chat, your Q&A function. But Jay, would you like to take the next one?
Sure. Yeah. So there were two questions that about the same thing. So it's probably something we should add. So Alejandro Pina and Mauricio Calvo-Calle both asked something to the effect of whether or not it will be possible to have an account on a site where you can kind of save your searches or save your predictions. Currently, that's not part of the plan, but it's not out of question either. So I mean, since we already got two questions about it, we'll definitely take that feedback and think about how we can make that work.
And I've just actually noted that down in our feedback sheet as well. I do see Bjorn's hand is raised. Was that
that was just like in addition to what Jay was just saying. I think our main focus has been it needs to be usable without having an account. So that most of the things do not require, because every time you're asked to register for something, it's a all kinds of hassle thing. But you're right, we should probably enable an account to save things. So you can just copy the link for future use, and you don't need an account. But having one to organize it for the people who want, I think that's a great idea.
Excellent. Thanks, Bjorn. And yes, we are tracking all that. So I've saved those points as well. The next B-cell related question was from an anonymous attendee that said, how well do the two methods correlate in predictions for discontinuous epitopes? So Mahita has kindly answered, ELIPRO and Discotope have comparable performance in terms of precision, while ELIPRO has better specificity than Discotope. When comparing top predictions made by either Discotope or ELIPRO predictions had lower correlation with known epitopes from 3D structures of antigen-antibody complexes. So thank you once again, Mahita. And Jay, would you like to take the next one?
Sure. Yeah. So there's a question from Chris Thorpe that says, for 3.0, can you do a GET request for a pipeline to get the input and output to pull into another tool? And yes, so we're providing a bunch of different endpoints. The main endpoint to get the result will actually provide links to all of the different elements of that output. So you will have a link to the peptide table. You have a link to all of your input data. So yes, there is that possibility.
Awesome. Thank you. And our third and final B-cell related question is from Jia Yi. And it is there a list of identified B-cell epitopes that was used for training the B-cell epitope prediction algorithm? Can we find the list on the IEDB? So Mahita has let us know that for the BepiPred 2.0 method, 160 antigen to antibody crystal structures from the PDB were used to train the random forest algorithm. The paper describing this list can be found here, and Mahita has actually shared the link to that paper as well. So if you'd like to take a look on PubMed, she shared that, and it's in that answered column for you as well, right at the bottom when you scroll to the end of the answered questions. So feel free to take a look at that if you haven't already. Thanks, Jay.
Thanks. And so there's another question from Mauricio Cavalcaya that says, is there an option in the columns to show select, unselect all, or faster way to select a few options? I'm just going to share again real quick to show you. Am I sharing the wrong screen? Are you seeing the tools?
We're seeing the command and the Google Doc, so no.
Okay. So hang
Feel
on,
free to try again.
fix that. There we go. So we don't have that option specifically, but when you go to display columns, so you can deselect one at a time, but you can almost select all, but by saying reset. And that actually, well, that's not working right now. But what it's supposed to do is supposed to reset it back to the default display, and which is going to be most of the columns that were selected.
Excellent.
Okay, and then there's another question, also from Mauricio. Any plans for visualization of promiscuous universal epitopes? That's not something we've thought about yet. I mean, we have thought about ways to kind of visualize, similar to the immunome browser view, where you have your protein sequence, and you can visualize kind of a map of instead of response frequencies, but prediction scores along the length of the sequence. And maybe you could imagine having kind of tracks for different individual alleles there that would kind of be similar to I think what you're getting at there.
Awesome, thanks, Jay. And I lied when I said that was the last B cell question. We did have one more come through from Fran Stanny, and it was, can we roughly assume that any discontinuous B cell epitope hits are found both in Discotope and LEPro have stronger predictive value than those observed in only one tool? And Mahita's kindly said yes. Since it is predicted by more than one tool, it could be considered a consensus. Is there anything else, Jay, on your side?
I don't see any that I can answer right now.
I can do one more. Franz Danny asks, will it be possible, or is there any plan to link HLA polymorphism data with the TCR repertoire information and provide a menu to filter these based on a given SNP RS? The answer is no, there's no plan. This would be super cool if you're working on something like this or know how to do it. We should actually, this is something we haven't really talked about so much. We very much host tools from other people, and if you have a unique capability like that, you'll be excited if you can get in contact with us. Tools that we host on the IEDB obviously get quite a bit of visibility, so we are excited to do that, and that would be definitely something we wouldn't know how to do. And I think with that, we're done.
Okay, excellent. Thank you very, very much, Jay, Mahita, wonderful presentations, Bjorn for chiming in there as well, and for allowing me to restate some of those questions and answers as well. So thank you all very, very much.